Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have x plus 1 the whole divided by x plus 2 into x plus 3, right? So what we've been given is dy by dx and we've been asked to find y. So let's write down what is our y. My y is nothing but integral of the given expression. So there we are, that's my y. I know that I will have to reduce the given expression into a much simpler format whose antiderivative I know from first principles, right? So it looks like I don't have it in that format. So how do we go about resolving the given expression into that format, right? So we have an expression, a rational expression of the type p by q. And I know that I can decompose this expression into partial fractions, right? So I can express it of the type a by x plus 2 plus b by x plus 3, right? Let me rewrite that particular expression. I'm going to keep y aside for a moment and I'm going to pick up the given expression to me and rewrite it in the format which we usually do when resolving a particular expression into its partial fractions, right? So let's write it at a divided by x plus 2 plus b divided by x plus 3, right? I know that you will encounter many of these rational expressions whenever we are solving integral problems. And if you look at my description, I have clearly explained how do we express a particular type of rational expression into its partial fractions, right? I request you to take a look at it. And the one that we are having right now on our screen is probably a very, very simple rational expression. And as you encounter more and more problems, you will probably face much more complex rational expressions. And I've given how to go about resolving them into partial fractions in the description, right? And the moment you get a hang of it, solving these problems is not that difficult, right? So let's go about solving this particular problem. So I have expressed it as a divided by x plus 2 plus b divided by x plus 3. So the idea behind this is to bring y to a format, which is like a sum of two functions, say function 1 and function 2, and I can easily arrive at the antiderivative of function 1 and function 2, and then I apply some rule, right? So I do cross multiplication of the given expression, and what do I get? Let's write down our numerator. My numerator becomes ax plus bx plus 3a plus 2b, right? I hope you folks are with me. I multiply a with x plus 3 and I multiply b with x plus 2 and I rearrange this expression, right? I know that I can rewrite my ax plus bx as x times ax plus b, and then I have my denominator as x plus 2 into x plus 3, right? So now I go back and compare it with what I have in the numerator, right? I have a constant term in the numerator, which is 1. And when I express it using a and b, I realize that it is equal to 3a plus 2b, right? So let me highlight that particular 1 as well. So my 1 is equal to 3a plus 2b as far as this expression is concerned. And I know that my coefficient of x, right, is nothing but a 1, right? Let me highlight this in green, right? And correspondingly, in the AB expression, I notice that this is equal to a plus b, right? I know that my a plus b equals 1 and my 3a plus 2b also equals 1, right? Now I'm going to solve for a and b, and when I solve for a and b, I realize that my a equals minus 1 and my b equals 2, right? This is what I get. I plug it back into the given expression, right, which I originally wrote. So my expression is nothing but a minus 1 divided by x plus 2 plus 2 divided by x plus 3. So now I know that I've resolved them into partial fractions. I go back to my y. My y can be rewritten as integral of minus 1 divided by x plus 2 plus 2 divided by x plus 3 times dx, right? And I can further apply the sum rule and rewrite my y as follows. Integral of minus 1 divided by x plus 2 times dx plus integral of 2 divided by x plus 3 times dx, right? Now I know that my y is reduced to a much simpler expression, right? This expression, be it the first one or the second one, they are of the type dx by x, right? And where my x is replaced by ax plus b. So all you folks are now familiar with what are the two rules I need to apply to solve this particular problem. I'm going to paste them down here for you. So these are the two rules which we'll be applying to solve the above expression. If integral of f of x dx equals g of x plus c, then my integral of f of ax plus b dx is equal to 1 by 8 times g of ax plus b plus c, right? Which means if I know my integral of f of x dx, then whenever my x is replaced by ax plus b, I can very quickly arrive at my integral of f of ax plus b dx. It is nothing but 1 by 8 times g of ax plus b plus c, where g of x is the integral of f of x, right? So let's connect it with what we have above, and I'm going to keep that minus 1 aside, right? And what we have in place of f of x and f of ax plus b, let's write that down. So there we are. So my f of x is 1 by x, and therefore my g of x equal to ln of mod x plus c. And then for the first expression, which is integral of dx by x plus 2, keeping the minus 1 aside, I have in place of x, I have x plus 2, which means that my f of x plus 2 equals 1 by x plus 2, and therefore my g of x plus 2 equal to ln of mod of x plus 2 plus c, right? So this is for expression 1, and I'm going to highlight this in green. And similarly, let's go to our y and highlight the first expression in green. And when I come to the second expression, we have a very similar expression, except that in place of x, I have x plus 3 this time. So my f of x plus 3 is equal to 1 by x plus 3, and my g of x plus 3 is nothing but ln of mod of x plus 3 plus c, right? So let us highlight this in a different color, say yellow, and correspondingly my expression 2 is also highlighted in yellow, right? Keeping the 2 aside. So now I think we have the answer for both the expressions in y. Let's go back to our y and write the answer. Coming to my y, I know that I'm going to be applying this particular rule to solve for y, right? So what does that rule state? My integral of f of ax plus b dx equal to 1 by 8 times g of ax plus b, right? So when we are in expression 1, my ax plus b equals x plus 2, which means my a equals 1, my b equals 2. So my answer to this problem is 1 by 8 times g of ax plus b, which means for expression 1, it is 1 by 1, which is a 1, times g of ax plus b, which is g of x plus 2. My minus 1 times g of x plus 2 is nothing but ln of mod of x plus 2. Let's keep the constant towards the end. So I have a minus 1 into ln, so I make it a minus ln. And then I go to my second expression. I have integral of, I keep the 2 aside, dx by x plus 3. Again, integral of f of ax plus b dx equal to 1 by 8 times g of ax plus b plus c, right? And in place of ax plus b, I have x plus 3. My a equals 1, my b equals 3. And my answer to the second expression is 1 by 8 times, which is 1 by 1 times g of ax plus b, which is g of x plus 3, which we have already worked out, which is nothing but ln of mod x plus 3. And remember, I have my 2, and we combine the constant for both the expressions and write them as one single constant plus c, right? So there we are. My answer to this problem is y equals minus ln of mod x plus 2 plus 2 times ln of mod x plus 3 plus c. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.